Okay, well here we are, and let's do a quick review of everything we've covered so far. All right, we're talking about imaginary numbers and that the square root of -1 is not possible in the real number system. Therefore, we use the letter I to represent the value of the square root of -1. Why would we do that? Well, let's take a look here. And just a quick idea about this is right here. Here is a number line, and we'll switch to blue. And so here's the x-axis, and here is a number line. And in the middle is 0. And over here to the left is -2. Over here to the right is +2. Those are two separate numbers. They are not the same number with just a negative sign. They're both 2 units away from 0. That's the absolute value. It's 2 units. But this number here, -2, is on the left side of 0, and the number +2 is on the right side. They're different numbers. When we're asking about square roots, we're saying what number multiplied to itself will give me 4? Well, there are two possible answers, either +2 or -2. That's because we're asking what number multiplied to itself will give us a +4. +2 times +2 gives us +4. And -2 times -2 also gives us a +4. Now, because a negative times a negative equals a positive, and a positive times a positive also equals a positive, it is impossible to find a number that multiplied to itself would give us a negative result. There is no way to come up with an answer for a question like this, the square root of -4. No number exists. No real number exists to give us a negative result. That's because to get a negative result, we have to multiply a negative number, like -2, times a positive number, like +2. It's the only way we can get a negative result. Since we know that, we can go back to our original question and say it is not possible in the real number system to get a value that would give us the square root of -1. We would also not get a value for the square root of -8 or -53 or -16 or -81. Any square root cannot come up with a real number and solution if it's a negative number already. The square root of -1, the square root of -2, none of those will give you a real number solution. So it's not possible. But as soon as we introduce the idea of imaginary numbers, we can separate out the negativity of the square root of -8 into the square root of -1 times the square root of +8. Those are two separate numbers, and we have isolated the imaginary part, or the impossibility, to talking about strictly the square root of -1. That's because we can convert any negative number into a negative times a positive by using -1. So in each case, we can say the negativity is the square root of -1 when we're trying to find the square root of a negative number. Separate those out, and we call that value I. I is equal to the square root of -1. Once we have settled on that, we can use I in our calculations. We can say the square root of -8 is equal to I times the square root of 8. And then we can work on the square root of 8 all by itself. That's the square root of 4 times the square root of 2. And the square root of 4 is plus or minus 2. And we have the square root of -1, which we're calling I. And then we're left with the square root of 2. So that gives us the square root of -8 is equal to plus or minus 2 I times the square root of 2. That's what the square root of negative 8 is. When do we use it? We use it when we're looking at quadratics or parabolas that do not touch or intersect with the x-axis. That's the case here with this value, y is equal to 2x squared plus 5x plus 4. If we removed that 4 and simply looked at y is equal to 2x squared plus 5x, we do get two real solutions, one right here and one right there. But if we turn around and take that equation, y is equal to 2x squared plus 5x, and add 4 to it, it's lifted, as it were, vertically enough units that it doesn't touch the x-axis at all. That's when we will get imaginary results in our use of the quadratic equation. So let's take a look. Here's the example. Y is equal to 2x squared plus 5x plus 4. A, B, and C. The A is the 2, the B is the 5, and the C is the 4. And we're using this equation right here. The quadratic formula is x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Plugging in 2 for a, 5 for b, and 4 for c, we get x is equal to negative 5 over 2 times 2 plus or minus square root of 5 squared minus 4 times 2 times 4 over 2 times 2. And that's the same as negative 5 over 4 plus or minus 25 minus this value here, which turns out to be negative 32. And it's all over 4. Okay, well, 25 minus 32 is the square, and it's all under a radical. It's the same as negative 7. So the square root of 25 minus 32 is equal to the square root of negative 7. Square root of negative 7 can't be found. We have to break it into the square root of negative 1 times the square root of 7. And as we said before, the square root of negative 1 is equal to I. So for this equation here, we turned around and we ended up looking at the same thing. There's our square root of negative 7. Plug it into the formula. It's here. And we can turn this into two answers. Right now we have it broken out as negative 5 over 4 plus the square root of negative 7 over 4, and negative 5 over 4 minus the square root of negative 7 over 4. Well, okay, but let's turn around and change the square root of negative 7 into I times the square root of 7. So here x is equal to negative 5 over 4 plus or minus I times the square root of 7 all over 4. And that is the final answer for the quadratic formula for this equation. Y is equal to 2x squared plus 5x plus 4. You can see it here. We can't see the value of I times the square root of negative 7 because our x and y axis involves real numbers here, and that's all we're working with. If we were working with a different coordinate system, we would plot real numbers on the x-axis here and imaginary numbers here. And this is where negative I is, and here's where positive I is. This is negative x, and that's positive x. Let's see if we have an example of that in here. Past this, I believe we will. A little further on. Here it is. This is the real number coordinate system. This is the x-axis, and here's the y-axis. But complex numbers have to be plotted on the complex plane. And the complex plane involves real numbers on what we called before the x-axis, and imaginary numbers, which are plotted on what used to be considered the y-axis. Now we can take complex numbers, such as 8 plus 5i, and plot it. We go positive 8, we go in the direction of positive 8 on the real number line, and then we go up positive 5i, and we get this coordinate right here on the complex plane. If it was negative 5i, we would go in a positive direction 8 units on the real number line, and then down 5 units on the imaginary number line, or axis, and we would end up right here. All right, I think that's enough for now.